I have a fun problem from the Blue Book. This is a JEE Preparation manual, and I think there's a slight mistake in the solution posted in the Blue Book, and so I'd like to publish this and just see if I get any feedback. E is Euler's constant. Any positive base raised to any real value is always going to be strictly greater than 0. That's very important as far as my approach, at least on this problem. E raised to any real value is always going to be strictly greater than 0. And everybody's familiar with the graphs of an exponential function. Again, this is problem 37 from the function part of the Black Book, I guess. All right, now, so we're going to suppose A is a solution to the given. And notice right here, it's important to include this one right here. It's understood that there's a exponent of 1. Now, we can easily deduce that A has to not be greater than or equal to 1. Okay, and that's very clear because if A was equal to 1, you would have e to the 1 right here, right? And this entire term right here is positive, right? This entire object right here is positive. Whatever f at A is, f is a real valued function. E to the f of A is guaranteed to be positive, right? So that means A cannot be equal to 1. It certainly can't be greater than 1, okay? Now, that negated relation leads us to conclude that any solution has to be between minus infinity and 1. Any solution to this given equation has to be a value bounded below by minus infinity and above by 1. Okay? Now, another way to write this, of course, is using interval notation. A lot of this sometimes confuses beginners because it sort of looks like an ordered pair, perhaps, or the GCD even. But so minus infinity comma 1 paren. Now y'all hear the paren just as a set building device, whereas minus infinity is not a number, it's a concept, so it can't be included. But the parentheses here, in contrast with the square brackets, indicates you exclude 1, which is what this more explicit statement says, all right? So what does this tell us? It tells us that minus infinity comma 1 must be contained in the domain of f of x. See, we want to know something about the domain of f of x. And so the strongest statement I can make is that minus infinity comma 1 is contained in the domain of f of x. Now the solution to the problem, let me go ahead and get that circled. So this would be the answer, is in my opinion. And again, I'd like some feedback if you guys can see anything wrong with my reasoning, because in the Blue Book, they said that the solution was, the Black Book, they said the solution was f of x just is equal to this. I don't think you can really say that. As long as f of x contains the solution interval, as long as the domain of f of x contains this solution interval, we're good, right? Because any solution to the problem has to be a number in this interval, all right? And so this interval must be contained in the domain of f of x. That's the strongest thing we can say. I don't see it the other way around. I don't know why the domain of f of x would have to be a subset of this. You know what I mean? So again, but that's what's published in the Blue Book. This is an equal sign in the Blue Book rather than subset. So anyway, y'all let me know on this what you think, because I'm kind of curious about it. It's a huge book. And anytime you have a huge book like that, often there's mistakes made in it because it's just too much to manage. It's more likely that I'm overlooking something, but again, I'd like some feedback from participants in this. It's not a competition. I think it's a qualifying exam for engineering students.